In an equilateral triangle, all side lengths are equal and all angles are equal. In an isosceles triangle, two angles and two side lengths are equal. But in a scalene triangle, all angles on all side lengths are unequal. Besides that, there are other inequalities also, such as that each side length should be less than the sum of the other two side lengths and so on. If you want to learn about all the inequalities in a triangle, you have come to the right place. Let's jump into the video straight away. Let's go. Hey guys, this is Vikas Sharma welcoming you on behalf of Exponent to Success to yet another video of ours. Exponent to Success is an initiative that helps to add an exponent to your learning curve. If you're new here or if you're landing on our channel pages for the first time today, I would strongly recommend that you subscribe to our channel right now so that you do not miss out on any future content from us. And do not forget to click on the bell notification also so that whenever any new content is uploaded, it comes right into your inbox. In the previous video, we discussed about some of the properties of a triangle, like the angle sum property and the exterior angle property, and maybe we'll make use of some of those properties in this video too. And if you missed that video by any chance, then the link to that video is on the top right corner of your screen. Just click on that and you'll be taken to the video straight away. We always love equality, and that's what this picture is saying. The equal to sign is always humble, and that's because it knows that it is not greater than anything or it is not less than anything. So that's a wonderful thing. We love humble things, we love humble people, and that's why we like equality. But in a triangle, we have to deal with various inequalities, and such as if I make a triangle like this where all three side lengths are different, then this is such a triangle is called scalene triangle. But what does this triangle tell about, what does it tell about the angles of these triangles? What about these angles? Well, we know the properties of a scalene triangle, that if the side lengths are unequal, then obviously the angles are also going to be unequal. That's why we know that if we draw an equilateral triangle, all three side lengths are going to be equal, and besides that, since the side lengths are equal, the angles are also going to be equal. And same is the case in an isosceles triangle, where if two of the angles are equal, then two side lengths are also equal. That also we discussed in the previous video, the link to which will again be given to in the end of the video. And in this video, my purpose is that we look or we prove the things by seeing and doing, rather than actually by doing it on a piece of paper or just theory. I don't want the theory. We want to be practical. We want to see triangles in which we see those inequalities happen and why they happen, because when we see something and when we do something, then only we understand better. So let me take you to a triangle that I have made, and let's see what we have in that. So here I have a triangle, and this triangle is such that it is, as you can see, it's the name of the triangle is triangle ABC. It has angle B measuring as 37.2 degrees, and the side opposite to that is 6.1 units. Now, what happens if we increase or decrease this angle here? This angle at 37.2 degrees. If what happens if we increase this angle? To increase or decrease this angle, what I'm going to do is I've got the slider. So if I just move along the slider, going on towards the right will increase the angle, coming to the left will decrease the angle. So let's try to see what happens to the angle, and meanwhile also look at the side length. How does that change or does that remain the same? Now, if it makes an angle of 37.2 degrees, it is making a side length, the side opposite to that angle is 6.1 degrees or 6.1 units, sorry. Now, if we increase the side length, the angle a little, let's increase it to 51.6 degrees, and we see that the side length has now increased to 8.4 units. If we increase it further, it has now become 10.5 units, and as we keep increasing the angle, you see that the opposite side length is also going on increasing. And as I keep increasing it, you see that the side length keeps increasing also. I can have it at a maximum of like if it goes to 180 degrees, then a triangle is not possible, because then it will just become a straight line and there will be no triangle. But as long as there are three angles, in which case here there are three angles where one angle itself is 177.6 degrees, and the remaining two angles are very small, because of which this triangle looks like this. But when I had it at 37.2, you saw that the side length was 6.1 units. Now what happens if we reduce it further? If we reduce it further, then obviously the distance between A and C is now becoming shorter, and the side lengths also keep changing. So as we bring the angle smaller, the side opposite to that keeps reducing, and as we keep increasing the angle, the side length opposite also keeps increasing. So this is what we notice in a triangle, that larger the angle is, the side opposite to that is going to be larger. Now, is this always the case? What happens when the angle becomes 0? Well, if the angle becomes 0, just keep looking at the points A and C. When the angle becomes 0, this and A comes and sits right on top of C, and it just becomes a straight line. That means when the angle is 0, that the triangle is not possible. So one angle has to be more than 0. It could be 0.5 degrees more than 0. It could be 1 degree more than 0. But it has to be more than 0 to make a triangle possible. Even if one angle is 0, then the triangle is not possible. It just becomes a straight line. And as we increase the angle, the triangle starts becoming possible again. So a triangle can exist only if if at least one of the angles is not 0 and one of the angles is not 180, because at 180 it becomes exactly a straight line, and again it is not a triangle anymore. But if you look at the angle C right here, you will notice that as I keep increasing one of the angle C is reducing, and if I bring it closer, then if I reduce angle B, then angle C is increasing, and at this point when it comes 0, angle C is exactly 90 degrees, and so is angle A, which is why the triangle is not possible, because two of the angles are adding up to 180 degrees while one of the angles is 0. Now what happens if we look at two of the side lengths and two of the angles together? Well, for that I've got another triangle, and let's have a look at that too. So this is a triangle, again triangle ABC, in which I have kept one angle constant at 60 degrees and the other angle right now is 22.85 degrees, and the side length opposite to 22.85 is 2.81 units, while the side length opposite to A or 60-degree angle is 6.2 units. Do you notice that 60-degree angle is larger than 22.85, and the side opposite to that BC is larger than AC, because angle ABC is smaller than angle BAC. We all learnt in the previous triangle that if I'm going to increase this angle, then the side opposite to this, which is 2.81, is also going to increase. But what happens to the other side? So I want you to look at this angle also. This, we already know that this side is going to increase the side length, but what happens to this side length? Well, if we take it a little further, it becomes 30.95 degrees. The side length opposite to that definitely has increased, and so has the side opposite to the 60-degree angle too. What if I take it little further? Well, the angle has increased, the side opposite to that has increased, and the side opposite to 60 degrees has also increased. What you notice in this triangle is that as I keep increasing the angle, the side opposite to the angle also keeps increasing. And in fact, both the sides are increasing. One of the sides here, the third side, is a constant which I've taken, that is not changing, but the other two sides are changing. So what happens when this angle ABC, when it goes above 60 degrees, what happens in that case? Well, let's take a case like that. Now angle ABC is 63.83, and look at the side opposite, it's 7.76 units, while this angle 60 degrees has a side length opposite to it of 7.49 units, which means that this side has now become shorter than the other side. The vertex which has a greater angle, the side opposite to that is going to have a larger length. Is that always the case? Well, let's increase it. Yes, now the side AC is always going to be larger than side BC, because as we keep increasing the angle, this side is also increasing, but at the same time this is also increasing. And if we bring that angle below 60 degrees, again you see, if I bring it very close to 60 degrees, I won't be able to get it perfectly on the mark, but uh, yeah, 59.96. So here you see the side lengths are almost equal, which means this is more or less like an equilateral triangle. But if I lower the angle, then you see that the side opposite has also become lower. If I increase the angle to more than 60 degrees, then the side opposite to the greater angle has become greater. Is that always the case? Well, let's see. I've got another triangle here in which, in fact, I made use of this triangle in my earlier video also, but we are not going to look at the sum of the angles. You may have a look that as we keep changing the angle, the sum of the triangle is always going to be 180 degrees, no matter how the angles change. Whatever kind of triangle I make, the sum of the triangle always remains 180 degrees. The angles are changing, but the sum remains the same. But what happens to the side lengths? Well, look at the side lengths here. I've got two angles 47.2 and 47.4, which are almost equal, but still you see 47.4 is a slightly larger angle than 47.2, and that is why the side opposite to that is 5.7 units. And slightly smaller angle 47.2 has got a slightly smaller side, which is 5.6 units. But the largest angle in this triangle is 85.4, and the side opposite to that is the longest side. Now, as we change the angles, what happens if we have a triangle like this, where this angle is 92.3 degrees? It is greater than the other two triangles. Now, if you look at the side opposite to this, that is 10 units, which is larger than the any other side. So, if which is the largest angle here? 92.3 degrees. And the side opposite to that is the largest side in the triangle, as you can see. And the smallest angle is 37.5 degrees, which means the side opposite to that is the smallest of all the sides. Now let's make angle A as the smallest angle. So to make A the smallest angle, we can do probably something like this, where A is now 35.5 and B is 46, C is 46.4, and B is the largest angle, and obviously the side opposite to the largest angle is still the largest, while the side opposite to A, which is only 3.4 units long now, so that is the shortest side when the angle A is the smallest. And if we take angle C to the be smallest like this, then you see that the side opposite to that is the smallest, and side opposite to the largest angle is now the largest. What happens if angle C becomes the largest? Then the side opposite to that becomes the largest, and the side opposite to the smallest angle, in this case angle B, is the smallest, which is 3.6 units. So that brings us to a theorem, and the theorem says that the side opposite to the largest angle in a triangle is going to be the largest, and the side opposite to the smallest angle in a triangle is going to be the shortest. And well, there's a converse of this theorem also. So the converse says, now instead of looking at the angles, now if we look at the side lengths. So let us look at the side lengths and then look at the angles. So here we've got a side length, which is the longest side length now, 5.6 degrees, and the angle opposite to that is 67.8 degrees. And the shortest side is 4.9 units, and this angle opposite to that is 53.4, which is the smallest angle. So can you see the correlation, that it is not only true in case of angles and angles and side lengths. So the first theorem said that as we increase the angles, the side opposite to that increases, or the largest angle in a triangle will have a side length opposite to that as the largest side or the longest side. Well, the converse of that theorem is also true, that if you have a side which is the smallest side in a triangle, the angle opposite to that is going to be the smallest angle, and a side which is the largest side in a triangle, the angle opposite to that is going to be the largest angle. So you can see many examples here. Look at a triangle like this. Longest side, opposite angle, longest. Smallest side, opposite angle, smallest. Look at a triangle like this. Smallest side, angle opposite, smallest. Longest side and angle opposite, largest. So this is always going to be true. So the converse of this theorem says that the angles opposite to the longest side is going to be the largest, and the angles opposite to the shortest side is going to be the smallest. Before we go any further, I would like to discuss a few things with you. So let us take 2 points. Let's take a point, say here, and let's take another point here. Now, can you tell me what is the shortest distance between those two sides? What are the different ways of going to this side to this side? Obviously, one way is that I go like this. One way is like that I go like this. One way is that I go like this, or I can also go like this. There are a number of ways from going to one side to the other side, from one point to the other side point. But what is the shortest distance between these 2 points? So well, if we look at that, then you can clearly see that if we start from this point to the other point, then the shortest distance between them is going to be a straight line between those points. And that is what I'm going to prove in this next example, that a straight line is the shortest distance between any 2 points. So if we have to go from here to here, this is the shortest distance possible. Any other way I take, if I take another point right here, and if I expect to go from here to here first and then from here to here, then this is not going to be the shortest distance to get from point A to point B. The shortest distance has to be point directly from A to B, not through the point C. So that is the point that I'm trying to make, that this side length AB is always going to be the smaller side length in a triangle, because if we go through a specific point which is not on the line AB, then we will have to take a longer route. And the longer route is that we go from A to C first and then from C to B, which is longer. So if we add AC and CB together, it is going to be longer than AB, because AB is the shortest distance between these 2 points, which is a straight line. Now uh, let's see this in terms of an activity also, another dynamic triangle that I've made. Let's have a look at that too. Well, so I've got this line segment AB. So we've got A here at the base, B is here, and I've got this line segment which is 13 units long. We've got another line segment which is 8 units long, and another line segment which is 7 units long. Now we want to make a triangle out of these three sides. Is that possible? Well, I can do what I can do is I can just move these points around. So I can bring this closer to this thing, and bring this closer to here, and wherever they meet together, then that forms a triangle. So this is like a triangle now. So it has formed a triangle. So one side is 8 centimeters long, the other is 7, and the longest side here is 13. So obviously if we look at, we know that the shortest distance from point A to point B is 13 centimeters, so that's a straight line. If we go via point D, then it is 8 plus 7, which is 15, which is greater than the third side. So you see, now what if I change these side lengths a little? What if I take this to be 6 centimeters, 6 units, and this to be 5 units? Well, let me change that and get back to you. So now that we have got this line segment as 6 units and this as 5 units, what happens if we bring these closer together? Can we form a triangle? Let's try and do that. So I bring this here and I bring this here. Well, they are not meeting right now, so I bring them closer together. Maybe they will meet. No, it doesn't look like. If I bring this here and then bring this here, no, they're going to not going to meet. If I bring it right over this line and this also over this line, you see that this does not form a triangle. And the only reason for that is that if you look at the sum of the two sides, 6 and 5, that is going to be 11, and that is going to be shorter than the third side. So the sum of the two sides has to be larger than the third side, then only a triangle is possible. Well, is a triangle possible if both the side lengths are if the sum of two side lengths is the same as the third side length? Well, let's have a look at that also. Let's make this line segment to be 7 centimeters and this to be 6 centimeters. What happens in that case? Well, so we've got this now. This is 6 units long and this is 7 units long. Now we have to bring them closer and form a triangle, which is ABD. So let's bring this here. Let's bring this here. No, I'll have to bring it closer together, here and here. Well, if I bring it slightly closer, then they should match. No. If I bring it here, then no, doesn't look like. They're still not meeting, though they are very close together. What if I bring this here and here? Well, the only way I can do that is if it is right on this line, then this point D is going to coincide over the other point, and it is here. Now you tell me, is the triangle possible? Well, it does not look to me, because one angle here, both the angles, angle A and angle B, are 0 degrees. The distance between A and D is 6 units, and the distance between D and B is 7 units. So if it is 6 plus 7 is 13, then the shortest distance, then the sum of the two sides is 13, and that means that point D should lie on the point AB, because the shortest distance between the point A and B is 13. So the only way that is possible is if point D is lying on the line AB, and therefore it does not form a triangle. So for a triangle to form, the only way we can do that is if the sum of the two sides is greater than the third side. Let's have another such case. Well, so we've got this now. Here one side is shorter. In fact, both the sides, if you look at them individually, 9 is shorter than 13, 7 is shorter than 13. But if you add the two sides together, 9 plus 7 is 16. So what can we form a triangle here? Let's try and bring them closer and see if we can. We bring this closer here. No, I'll have to take this a little above. Well, there we are. So we are forming a triangle there, and whenever the sum of two sides is greater than the third side, then only a triangle is possible. Otherwise, as you just saw, Even if the sum of the two sides is the same as the third side, then also a triangle is not possible. And that is the reason why this dog is so confused when he is trying to solve a triangle inequality and he sees that the sides are 5, 3, and 26, because the sum of the two sides, the sum of the two shorter sides, 5 plus 3 is 8, and the third side is 26. So if he solves for a question and he finds that the third side is 26, then he knows that a triangle is not possible, and which means that he has done the question incorrectly. So that is why you must make sure that whenever you're finding such inequalities, you should make sure that the sum of the two sides, the sum of the shorter two sides, is always greater than the third side. So that brings us to an end of the video. I hope you enjoyed the video thoroughly and you learned something useful out of it. In case you did, I would like to hear all about it, so just head down to the comment section below and leave in your comments for me. In case you are facing any problems with any of your questions, or in case you want me to cover any specific topic, just mention that in the comment section too, and I'll surely get back to you with a video. I would surely recommend that you hit on the like button below and share the video link with your friends so that they also learn something useful out of it. And in case you haven't subscribed to our channel as yet, this is the right time to do so. You see a subscribe button right in the center of the screen. Just click on that and you'll be subscribed to our channel straight away. And do not forget to click on the bell notification also, so that any future content is delivered right into your inbox. As a part of your continued learning, you can click on these videos shown on the left side here. Please like and share the video. Take care. God bless.